Right, so let's do our first example of a hypothesis test. So here in this square, I've got our, I guess, merged cell. It's not a square. I've got our prompt, right? So a car company has claimed that their eco-friendly sedan averages 31 miles per gallon. We assume that gas mileage is normally distributed. You can randomly select 8 of these sedans from a local car dealership and test their gas mileage under similar conditions, right? So what do we know? We know that we are interested in the miles per gallon that this eco-friendly sedan gets. We assume that that gas mileage is normally distributed and our sample size is small, right? 8 is small. So what do we know when we have a small sample size, but we assume normally distributed? We can use the t distribution, right? So our type of test here is a t distribution test of the population mean. Now, which direction is it? We'll talk about that in a second, right? But for now, the parameter we're testing is mu, the population mean of the miles per gallon, right? Our null hypothesis is that mu is equal to 31. Our alternative hypothesis, in this case, this company is claiming that they're eco-friendly, right? So we are interested in whether mu is less than 31, right? We don't care if mu is greater than 31 in this case, because if mu is greater than 31, then it's even more eco-friendly and we're happy, right? We can do a test whether it's deviating significantly one way or the other if we wanted to do a two-sided test. But in this case, I believe the appropriate thing to look at is we're interested in testing their claim that it's 31. Well, we're interested if it's lower than 31. Again, because if it's higher, great, it's plenty eco-friendly, right? In this case, we're concerned with whether or not it is lower than 31. So now we have a one-sided lower tail t-distribution test of the population mean, right? So that's the type of test we are doing here. Now, because we have a t-distribution test, what is our test statistic? Our test statistic t is x bar. I'm going to use some typed out shortcuts because I cannot use fancy symbols in Excel, but our test statistic is x bar minus the value we're assuming in our claim divided by the standard deviation s divided by the square root of n, right? Because this s divided by the square root of n is the standard error of x bar, right? So that's going to be our test statistic. These are all values that we can compute using our sample data. And our p-value here is well, I guess we'll go ahead and change this to a lowercase t, right? So then the p-value, because we're looking at a lower test, is the probability that t is less than our test statistic when t is distributed with a t distribution. That sounds funny. With degrees of freedom, and -1, right? T has a t distribution with degrees of freedom n -1. That is what we are given, right? The probability of being, let's go ahead and rephrase that then, right? Or the area under the curve t with degrees of freedom equals n-1 curve to the left of our test statistic. Right? That's the same. These two are the same thing. Right? We're asking for the same thing. So our n is 8. We already know that. We were given that in the question. And sedans, our sample mean is the average of our miles per gallon of our sample. The sample standard deviation is our standard deviation dot S. Remember, we need to compute the sample standard deviation because we do not know the real value, right? So then our test statistic, T, is going to be equal to the sample mean minus 31 divided by our sample standard deviation divided by the square root of n. Right, so our t value here, our test statistic, is minus 2.04, give or take, right? So that is our test statistic. The p-value, right? Remember, our p-value is the probability of getting a test statistic as extreme as ours or more from 0, assuming that our null distribution is true. Remember, this is all the probability of flipping a coin 10 times and getting heads 10 times, assuming that the coin is fair. This is the same idea. The probability of getting a sample mean, right? Because our sample mean is 29, which is far from 31. What is the probability of getting a sample mean 29 when the mean is actually 31? That is what we're testing here, right? So our p-value is going to be the t-dist of this value, degrees of freedom n minus 1, and cumulative is true. Remember, this is how we're going to find the area under the curve to the left of this value. And we see that it is 0.04. Meaning what? Meaning that there is a 4% chance of getting this value, a 4% chance of this happening by chance, right? By sampling variance, right? Because you can have sampling variance. You can flip a couple heads in a row, even if your coin is fair, right? But here we're talking about the probability of finding this. If this is our true value, the probability of finding this one so much smaller, as this small or smaller than the truth, is only 4%, right? So with an alpha value of 0.05, this p-value is smaller than that alpha value, and we thus conclude that we reject the null hypothesis. We conclude that we reject the null hypothesis, that mu is 31 in favor of the alternative, mu is less than 31, right? So with that, our p-value is less than our alpha value, and we reject the null hypothesis.